The moon. In this lesson, we're talking about moon facts, the movement of the moon formation, phases of the moon, tides. We're going to answer the question, what if the moon disappeared? We're going to talk about the misconception of the dark side of the moon, and we're going to talk about the moon illusion. Moon facts. The average distance from the moon to the Earth is 384,404 kilometers. The moon is drifting away from Earth at a rate of approximately 3.8 centimeters every year. This means that the moon used to be a lot closer and therefore a lot bigger in our sky a long time ago. The diameter of the moon is 3,475.9 kilometers, which is about 27% the diameter of Earth. We always see the same side of the moon since the moon and Earth are locked in orbit. Its surface temperature ranges from negative 233 to 123 degrees Celsius. A person would weigh about 1/6 as much on the moon as they do on Earth due to the weakened gravity, and the moon's mass is about 1.23% of Earth, so it's a lot smaller than Earth. Movement of the moon. It takes the moon 27.3 days to orbit the Earth. The moon's orbit around Earth is elliptical, so it's not circular. Elliptical means like an oval, like we see here. One part of the orbit, the perigee, is closer to the Earth than the other, the apogee. So the perigee here, we're going to get a shorter distance than the apogee, which is right here. Movement of the moon. The moon always presents the same face towards Earth. In order to keep the same face towards Earth, the moon must rotate once every orbit. You can see this is one complete orbit. So every time the moon moves, it actually spins. So if we were to do something in between, it would look something like this. But no matter where the moon is in its orbit, it's always going to face the exact same direction. And that's why we're always going to see the same face of the moon. Since we see the same face, that means it must be spinning. So it's spinning in this direction here in order to continually facing the same direction towards Earth. Moon formation. There are three main theories on how the moon was formed: the co-formation theory, the capture theory, and the giant impact hypothesis. Number one, co-formation theory. If two massive objects collided, the remains under the influence of gravity could have been drawn together to form the Earth and the moon. So if you have a very large object and another very large object and they smash together, you're going to get a huge explosion, a whole bunch of debris everywhere, and eventually that debris is going to form into the Earth and the moon. In the co-formation theory, both bodies should have a similar heavy element composition in their core. This is not the case. So since their cores are not that similar, this is one argument against the co-formation theory. Number two, capture theory. The capture theory states that a rocky body, the moon, was formed elsewhere and passed too close to Earth. As it did, it entered Earth's orbit and was captured. So if you have Earth here, and you have the moon sort of flying this way, it gets a little bit too close. And instead of continuing on, it gets captured by Earth's orbit and just simply orbits around Earth instead of continuing its path. So Earth would have captured it. The capture theory would explain the differences in the composition of Earth and the moon. However, one strike against the capture theory is that it would be very difficult to capture such a large object traveling at such a speed as it passed through Earth's orbit. Most likely, that moon would just continue to go because Earth's gravitational pull isn't strong enough to capture such a large object. Giant impact hypothesis. Although not without its faults, most scientists believe that the moon was formed when an object smashed into early Earth. This object, known as Theia, was a Mars-sized body. The theory states that when it collided with Earth, it threw vaporized chunks of the planet's crust into space. Gravity bound the ejected particles together, creating a large moon. So you have Earth, and you have this Mars-sized object smashing into it. When it did, it threw a whole bunch of debris up into the atmosphere. All that debris eventually coalesced into the smaller moon that orbits Earth now. And according to NASA, when the young Earth and this rogue body collided, the energy involved was 100 million times larger than the much later event that was believed to wipe out the dinosaurs, the asteroid impact. So it was a huge explosion. It would have decimated both objects. Eventually, the Earth repaired itself, and the debris from Earth and this Theia object came together to form the moon. Now again, we don't know what the answer is. We don't know how the moon formed, but most scientists believe the giant impact hypothesis is the most likely. Phases of the moon. So you can see this is a series of days where we go from a new moon back to a new moon. And you can see the different phases of the moon during that time. Phases of the moon. A common misconception is that the phases of the moon are caused by the shadow of the Earth. Instead, the phases of the moon are the result of changing view angles throughout the month. So if the sun is here, and it's always shining its light this way, and we're here on Earth observing, our view angle is going to determine what part of the moon that we see. So if we're standing right here, we're not going to see anything because the entire part of the moon that's illuminated is on the far side, and we can't see that far side. All we see is this dark area here. Since we only see the dark area, we see a new moon that looks like there's nothing there. Conversely, if the moon is on the other side of Earth, then we're going to see the part of the moon that's completely illuminated by the sun. As a result, we see a full circle making up the moon in the sky. And then everywhere in between is going to make up the part of the moon that we see. If we're standing over here, then we're going to see half of the moon. If we're standing over here, we're going to see half of the moon, and then a quarter, and so on. We can only see the part of the moon which has been lit up by the sun, like I just mentioned. At new moon, the part lit by the sun is facing away from us. Since the lit part is facing away, the moon appears dark. So let's reiterate those 2 points. At full moon, that's this guy over here, the lit part by the sun is facing towards us. Since the lit part is facing towards us, the moon appears fully lit. All the phases between new and full moon are the result of us seeing a portion of the lit side. What I'd like you to do is pause the video and copy this diagram into your notes. At each point, I'd like you to draw a little person to represent the viewing angle at that different stage. How the moon influences the tides. This is the other thing that most people understand about the moon's effect on Earth. The tides, or the tidal bulges, are caused by gravity pulling on the bodies of water on the Earth. There are two gravitational bodies that affect tides, the Sun and the Moon. The Moon is much closer to the Earth, so it has a much greater influence upon the tides. Now the Sun is much bigger, but since it's so much further away, its impact is less. Whether the Moon is on the right-hand side or the left-hand side, you're going to get these tides, these bulges on both sides of the Earth. And that's because we're getting a pull this way, but we're also getting the centrifugal force that way as the Earth is spinning. So you're going to get a tide on the other side as well. When the Moon, Sun, and Earth are in line, so that's this guy right here, the gravitational pull is added. So you're going to get the Sun plus the Moon, and that's going to get a large tidal bulge. When the Moon and Sun are at right angles to each other, the effects partially cancel out. So you're going to get the Moon minus the Sun, and this is called a neap tide. So again, the Moon still wins out, so you still get the tide going towards the Moon, but it's less because of the impact of the Sun. As the Earth rotates, a different part of it faces the Moon, and so a different part of the Earth experiences a high or low tide. Remember, the Earth rotates every 24 hours, so although we always see the same side of the Moon always sees a different side of Earth. The part facing the Moon experiences a high tide, while the side at the right angle to the Moon experiences a low tide. So if we had an Earth here and a Moon here, this would be our high tide here, and this would be a low tide. This would be a high tide, and this would be a low tide. Coastal areas experience 2 low tides and 2 high tides every lunar day, or every 24 hours and 50 minutes. So what I'd like you to do is pause the video and have a look at number 3. It's a really interesting look at the Bay of Fundy, which experiences these high and low tides and is well documented. What if the Moon disappeared? So what I'd like you to do is I'd like you to pause the video and have a look at number 4. While you're watching, I want you to write down the 3 major things that would happen to Earth if the Moon disappeared. So after watching the video, you should have got these main 3 things. Number 1, the tides would be very different. We've already talked about the fact that the Moon influences the tides. If the Moon went away, our tides would be a lot lower because they'd only be influenced by the Sun and not the Moon as well. Number 2 is we get a lot less moonlight at night, which would alter the food web. You'd have animals that rely on the light from the Moon being all confused and not able to hunt and hide as well as they normally would. And as a result, you're going to see significant changes to the food web and the feeding relationship within it. And lastly, and the most important, would be the Earth's tilt would be significantly affected. The Moon stabilizes the Earth. It keeps it from wobbling and changing its tilt. We want to stay at 23.5 degrees. That keeps our seasons constant and our climate pretty much the same. If our Earth wobbled a lot, so say it went from 23.5 degrees to 90 degrees, what would result would be a cataclysmic change to our current climate. Misconception, dark side of the Moon. So a lot of people refer to the far side of the Moon as the dark side of the Moon, as in the part of the Moon that doesn't receive any sunlight. But there is no dark side of the Moon. The dark side of the Moon should really be called the far side of the Moon. The far side gets just as much light as the near side. During a new moon, the near side of the Moon is dark and the far side of the Moon is fully illuminated. Keeping in mind, we only see the same side. So this side is still seen, but to see it, you actually need to fly to the other side of the Moon and have a look from there, using either a rocket ship or a satellite. So this is what I was referring to. So we're always going to see this point right here, because that part always faces the Earth. But keep in mind, the other side is still there, and it's still receiving sunlight. In fact, during a new moon, like I was saying, that's all that's receiving sunlight, is the far side of the Moon. During the first quarter, that's the far side in red, and you can see that half of it is receiving sunlight, and the rest of the phases are the same. So here's a picture of the different sides of the Moon. So this is the side that we see, and this is the side that we don't see. And they're actually quite different looking. But again, the only way that you could see the far side of the Moon is if you were to fly around the Moon and have a look at it, either with a spaceship or some kind of satellite, because from Earth, we're only ever going to see this side, because it's locked to Earth's orbit. The Moon illusion. Many people believe the rising moon is larger than when the moon is high overhead, and this is a fair thing to think. If you take a look at the moon as it's rising over the horizon, it does look bigger than when it's in the sky. But the effect is entirely an illusion based on your perspective. So as the moon rises up into the sky at night, the moon is exactly the same size. It does not get any bigger. Now what I'd like you to do is I want you to pause the video and watch number 5, because it gives a really good explanation of this moon illusion. Now there are times when the moon is slightly bigger, and that's when it's at its perigee. Remember we talked about that earlier? The perigee is when the moon is closer, and the apogee is when the moon is farther away. When it's at its perigee, we call that the supermoon, and it's approximately 11% larger than when it's at its apogee. And the reason it's smaller when it's at its apogee is that it's farther away. This change, however, is on a monthly basis, not an hourly one. Any difference you see during a single night is due to the moon illusion. The rest is in your head. And that concludes our lesson on the moon.